everyone, we are going back to this 2018 FRQ. This is the calculator section. And this is number 1. It says people enter a line for an escalator at a rate modeled by the function r given by r of t equals 44 times t over 100 to the third times 1 minus t over 300 to the seventh. And that is for 0 to 300. After 300 seconds, the rate people are getting in line goes to 0, which means no one is getting in line. It says R of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time t equals 0. So I included parts A and B here because they can be used for part C. So part C says for t greater than 300. So after 300 seconds, what is the first time that there are no people in line for the escalator? And so I guess we don't really need part A. That was already used in part B. But for part B, you figured out at time 300 that there were 80 people in line. And so this is actually just a 1-point question because at time 300, there's 80 people in line. We also know that after 300 seconds, no one else is getting in line. So all you have is people leaving the line at that time. And they're leaving the line at a constant rate of 0.7 people per second. And that's a linear rate of change, right? Every single second, 0.7 person is getting out of line. So if you just take 80, you know at time 300, there's 80 people, and divide it by 0.7, that is going to tell you how many seconds it takes those people to get to exit the line. So that gave us 114.2857. 114.2857. Right, so there's 80 people at time 300. No one else is getting in line because the rate went to 0. And then they're leaving 0.7 person each second, right? They're leaving at that rate. So that's going to take 114.2857 seconds for those 80 people to get out of line. The only thing that you need to add on to this is 300. So 300 seconds have gone by, and that's when we have 80 people in line. And then it's going to take another 114.2857 seconds for those people to leave the line. So the 80 people, we were already starting at 300 seconds. And then the 114 this time is how long it takes them to get out of line. So 300 seconds have passed. That gives us 80 people in line, and then an additional 114.2857 seconds for them to leave the line, and then there's no one in line at that point. So for your answer, you would have 414.285 if you truncate, or 414.286 if you are rounding seconds. The rubric for this question, it's just 1 point. And it says, based on part B, the number of people in line at 300 seconds is 80 people. And then you can see they wrote it kind of differently. You might like that they have the 300 seconds that they're starting with that, and then they're adding on the 80 divided by 0.7 to give the amount of time it's going to take those 80 people to get out of line. And they got the same answer, 414.286 or 414.285. And that is it for part C.